So here's our last video series on the Math 241 class. So we're going to deal with decimals, and this will be the decimals part 1. So let's talk about what we know so far. So everything that we've worked with in regard to base 10 blocks, everything so far was a flat represented 1, a long represented a flat represented 100, a long represented 10, and a unit represented 1. So now notice we're just changing all of that with our decimals, and now the flat represents 1, and the long represents a tenth or 10 hundredths, and the unit represents 1/100th. So when you have the grids here, each of these with 100 unit cubes, this makes up one whole unit. And so if I want to represent 57 hundredths, then I should just be able to highlight 1, 2, 3, 4, 5 longs, and 1, 2, 3, 4, 5, 6, 7 units to represent 57 hundredths. So you can think of it as 5 longs and 7 hundredths, or you can think of it as 57 of those hundredths cubes. Second one, 25 hundredths. We're going to highlight 2 longs and 5 hundredths. With the 85 hundredths, we're going to represent 8 longs, and then the 5 units to represent hundredths. And then this last one here, we've got 1 and 45 hundredths, just means that we need all of this first one, which would be 1, and then this next one needs to represent 45 hundredths. So we would represent it with 1, 2, 3, 4 longs and 5 hundredths, which would give us the 1 and 45 hundredths. When we talk about percentage, we're talking about what it means, and it's per hundred, which is another name for hundredths. So when we take 3/4 as a fraction, and I want to write that as a decimal, we're thinking about what that could be is equivalent to hundredths. And since 4 is a factor of 100, we could multiply it by 25, but we would have to multiply the numerator by 25, so that would give us 75 hundredths, or 75 hundredths is the decimal, and the percent would be 75%. And with the grid, you would want 7 longs and 5 hundredths. 2/5. Think about what you could do to make that equivalent to tenths, which could then be equivalent to hundredths, but that would be 4/10, which is the same as 40 hundredths. So the decimal would be exactly how you read it, 40 hundredths or 4/10. These are the same. The percentage would be 40%, and you would have 1, 2, 3, 4 longs. In regard to the number line with decimals, so far everything has been whole numbers. When we're looking at measurements, so what I'm asking you to do now is to think, let's look inside that 0 to 1, and we just want to zoom in on that piece there. And so that gives us from 0 to 1, and then everything inside there would be tenth. And 1 is the same thing as 10 tenths, and 0 tenths is the same thing as 0. So we just looked at it from here to here, and all of these numbers were what we showed before that was in this area right here. So we just zoomed in, and that gave us this area. So now I'd like to take what's inside from 0 to 1/10, which is 0 tenths, to 1/10, which is the same as 10 hundredths. And we'll see so we just open that up there, this area right here, and then we created, notice that we got smaller from 0 tenths to 10 hundredths. And this would also be the same as 0 hundredths. And so that distance inside there we see are also from hundredths. So it just continues to get smaller every time we subdivide another interval. Here we want to look at how we can place decimals in order from least to greatest. So this first one here is actually 3/10 repeating, and then we just have 3/10 terminating. We have 1 and 25 hundredths. We have 1, we have 25 hundredths, and we have 5/10 or 50 hundredths. So we can kind of look at it from 0 to 1, and we'll make this one 1 1/2. So we know we're going to see 1 1/4. And we know we're going to see 1. And then some benchmark numbers. So we know that's going to be 5/10 or 50 hundredths. See that here. We see that one here. And then halfway there would be 25 hundredths. So we see it here, see it here. And now this 3/10 and 3/10 repeating. So notice there's a difference. There's a difference here and in this one. So the 3/10 would actually come first. So we would say maybe right there and then right there. So this would be 3. This one would be 3/10 repeating, and this would be just 3/10. So that would be placing them in order from least to greatest. If you look down here, I would want you to look at the whole number, 5, 6, 5, 5, 5. So let's go ahead and make that from 5 to 6. And so we know that with this one, we're just a little bit more than 6. So we'll just drop down here. So this is the 10,000ths place, that 4. So this would be 364, 6 and 364 10,000ths. And so we see that number. And then next, let's kind of work our way. Here's 5. So 5, this number is going to be just right inside there approximately. And then we have our benchmark, so about halfway, 5 and 5/10. And so all of these, here's 5, and so we'll give this So we've got 5 and 40,364 hundred thousandths. So a very small number here. And then these two, notice, are just 4 thousandths apart. So we'll say that that one, if this was probably 5 1/4, so maybe right here, put this one would be 5 36 hundredths, 364 thousandths. So again, just trying to place them all on the number line from least to greatest. These next two slides, and we'll wrap up part one, where we want to look at common errors. These common errors and misconceptions of the students. So when you think about it, the longer decimal is larger. Well, so far, students have known, we look at 3,000 compared to 300. Well, 3,000 is a bigger number, even compared to 3. It's got more digits. So a misconception that students have when they translate that to decimals is that the longer number of digits would be larger, and that's not the case because 75 hundredths is much larger than this one. Or they may look at it in a flip-flop way and think, well, it's the shorter number, so the shorter decimal has to be larger. And if you flip-flop your thinking here, of course you can flip-flop it on the top one with the larger decimal. There's also this interval of 0 that students believe that doesn't have any impact. And you can also increase a place value and do a placeholder of 0. Notice I did that here because 350 thousandths is the same as 35 hundredths. But this 0 actually has meaning. It's actually 305 thousandths. So just because that 0 is in there doesn't make it doesn't make it larger, because this has 2 decimal points, but that 0 does have an impact, as it would here if you added it and increase that place value for 350 thousandths. Also, students look at decimals thinking, well, it's 0 to 1, yes, but anything that's a decimal has to be smaller than 0. So they actually think that 0 is larger than some of these numbers, so those numbers would end up becoming over there. That's actually showing that that would be beginning into the negatives. So when you're thinking decimal places, you are starting at 0 and moving to 1. So all of your decimal places less than 1 are going to be greater than 0. So that's a misconception that students think that 0 is larger than that. And I really do believe that a lot of that comes from when you look at the numbers here. Notice there's no whole number in the 0 spot. So that means that 0 must be bigger than this 254 thousandths, because there's no 0, there's no decimal point to the right, and it's actually just the opposite. This would be larger than 0. Then you've got your reciprocal thinking, which is very common. You see 4/10, and students will make that 1 divided by 4, or they say 6/10 and they make that 1 divided by 6, not thinking about what the 4 represents and what the 6 represents. And that is that stress of place value and the importance of reading the number correctly. And this is a great example of using the fraction tiles from ABCYA, that website. It actually compares the fraction tiles to fractions and decimals and percentages. But this last one here is always tricky for the students because it also goes back to that larger number is more digits. It's got to be larger. Well, 75 hundredths is the same thing as 750 thousandths. And you can use a zero placeholder, and now that you do that, you can see that they're equal.